So now let's look at the solution to exact differential equation. So we are going to look at how to solve them. What we did was just to try to verify whether it's an exact or not. Now, before you can solve this kind of differential equation, like the exact one, first you have to be exact. If it is not exact, then you have to use different way to solve it. Okay, but for now we are going to solve the ones that are exact. So normally when they give you the thing, try to show whether it's exact first before you start the solution. So now let's start with this. We have already established that delta u delta x dx plus delta u delta y dy equals what? 0. Where we said that m in terms of x and y dx plus n in terms of x and y dy is also equals to what? 0. So per looking at this one, we can say that no, this is dx, this is dx, so we can compare this and that. They are the same, meaning that this one will be delta u delta x equals to m in terms of x and y. Is that okay? The same thing will apply to this one, delta u delta y equals to n in terms of x and y. Good. Now at this point I can try to make delta u the subject here. So let me do that one here. Okay, let me bring it here, this direction. I have delta u delta x, which is equals to m x y. So cross multiplication, I have delta u, which is m x y delta x. So if I take partial integration of this, then I'm going to, this one will go with this. So I have u equals integral of delta m x y delta x plus, when you integrate indefinite integral, you need to bring constant. But in this case, because it is partial, the constant you don't write c, but rather you ask yourself, we are integrating with respect to what? X. We are integrating with respect to x. So if you are integrating with respect to x, the constant should be in the function of the other variable. So the other variable here is y, so f of y. That's how we do it. So if I take the other one, which is delta u delta y, which is equals to n in terms of x and y, the same thing. So delta u will be n in terms of x and y. Then if I take the integral on both sides, my u will be integral of n in terms of x and y plus, let's say, j of what? X, because here we are integrating with respect to y. So the constant should be in the function of the other variable. So that is how it is done. And if you look at this one and that, they are the same. This is u, this is u. Have you seen that? They are the same. So what you do is that your solution can be this or that. But sometimes they differ a little bit. So what you do is that after finish solving it, you just compare the j of x. You look for a number or a variable here that is contain only x, then you put the j of x to it. Then you come here and look for a variable that is contain only y, then you put what? F of y to it. So now, after getting this, okay, already I have explained to you that u is always equals to c, and this is our general solution. You can also write it as this: u in terms of x and y is equals to c. So this becomes the general solution. Yes, this becomes the general solution. So take note of that. Okay, and you know where we got this thing from? It was getting from the fact that the u is equals to 0. So when we take the integral on both sides, we have u in terms of x and y to be equals to the constant, because when I integrate them, it's 0 plus the constant. So that's where that thing is coming from. So you take note of that. Good. Now let's look at an example. Look for this question. We said that show that the differential equation that I've shortened it, this is exact and find its general solution. So first thing they say show. Even if the question did not tell you to show, you have to show. And you have to find out. So that's the first thing. So we already know that the one that is attached to the dx is m. So m solution. M in terms of xy will give us 3x squared plus 4xy. So I will take the partial derivative with respect to y, and that will give us 4x. Because all of these become constants. If I differentiate y, that will give me 1, so we have 4x. Then I have n in terms of x and y is equals to 2x squared plus 2y. Is that okay? If I take partial derivative with respect to y, now let's check. Here with respect to x, so the y goes to 0. If I differentiate it, that will give me 4x. So now you can conclude that since delta n, delta m, delta x, y is equals to delta n, delta x, which is equals to 4x, the equation is exact. Have you seen that? So since that is equal, is exact, so you can start doing the solution. Let's begin with our solution. We have already established that u is delta u delta x is equals to m of xy, okay? And we have also, from the exacting, when we are checking for the exacting, realize that m is the whole of this one. So I can write this one as delta u delta x to be equals to 3x squared plus 4xy. You see that? Next time I'll go straight, so that I can have delta u to be equals to 3x squared plus 4xy dx. So we take the integral on both sides. So when we take the integral, we have u equals, now this one we are integrating partially with respect to x. So meaning that here, if we integrate this, we have x cube. I know you know how to do it. Then if I integrate this one, this and that hold constant. So I'm going to integrate this. That will give us 2x squared y, because this is constant. And if I integrate, I'll have x squared over 2. 2 will cancel this for 2. Then we have this, right? Plus, as I said, because I'm integrating with respect to x, the constant will be a function of what? Y. Good. So looking at it directly, if I want to pick the n, we know that the n will be in terms of this one, 2x squared plus 2y, right? So if I'm doing it directly, I'll have the u to be equal to the integral of 2x squared plus 2y. But this time it will be with respect to what? Y. Because the n is always be given as the u delta y equals n of xy. Now if I'm to integrate this, I have, now here I'm integrating with respect to y. Remember, for integration, when I have a constant, I will just attach what I'm integrating with respect to the constant. So this is a constant, so I just attach this one to this. That will give us 2x squared y plus, if I integrate this with respect to y, I have y squared, or that will be y squared over 2. The 2 will cancel this, and the constant you can use different variable. Should be in terms of x, a function in terms of x. Okay. So now that we have this, let's check something. This and that, we are saying they are the same. Let me name this one equation 1. And here to equation 2. We are saying two of them are the same. So if two of them are the same, meaning that we can compare. So for the comparison, the only thing we compare is the function here, the constant f of y and g of x. So you come to this place and you search where we have only x variable standing alone. When you look there, you don't have any x variable standing alone, then g of x is 0. Is that okay? But if you look at here, we have only x variable standing alone, which is x key. So meaning that here can say that g of x is equals to x cube. I hope you understand this one. Look for something that is in terms of only x, and that's what I have here. Very simple as that. Then I come to the other one, f of y. So f of y, I have to, that is equation, so I have to come to equation 2 and check something that is in terms of only y. If you don't have some there, then g of f of y is 0. So f of y at this point is y squared. Okay. Now when you finish, you can decide to pick this one or that. Any one that you pick, you get the same answer. So I'm taking the equation 1. This one, if I pick this one, I have u equals x cubed plus 2x squared y plus. Now f at y, we have y squared. Have you seen it? If someone also pick this one, we are going to have 2x squared y. 2x squared y is here. Have you seen that? Y squared. You have y squared here. You have, yes, y squared is here. Then g of x, by our g of x is x cubed. So if I put x cubed, you see that it's here. So it's the same thing. So whatever you pick, you get the same thing. Now that we have this, already you said that to get the general solution is always equals to c. And you know that this u is the same as this. So in place of the u here, I put the whole of this one here. So do it to give us x cubed plus 2x squared y plus y squared is equals to what? C. So this one becomes our general solution. This becomes our general solution. I hope, yeah, okay. Okay. Now I'll solve one example, one more, then I'll give you one to try. Alright, so now let's look at example number 2. Solve the initial value problem. So this is a problem given, and this initial condition. There has been given an initial condition y of 0 equals negative 3. So when we finish, we will put it there so that we get a particular solution. I have already told you. And when the initial condition is given, then when you use it, it becomes a particular solution, no more a general solution. Alright, so first thing you have to check whether it's exact. But before you do that, you have to multiply through by the dx so that here too will get something. When I multiply through, I'm going to have 2xy minus 9x squared dx plus 2y plus x squared plus 1 dy equals 0. We said that the one that is attached to the dx will always go for the m. So I'm going to have m in terms of xy will equals to 2xy minus 9x squared. So when I take the partial with respect to y, so with respect to y I have 2x. Then I come to this side, and that one is going to give me 2y plus x squared plus 1. So delta y x, that will also give me 2x, because this will go to 0, this will go to 0. So that's what I have. So here I don't need to write English again, because you realize that these 2x, these 2x, so since they are equal, then we can say that they are exact. And if they are exact, what can we do? We can solve it using the procedure we just used. So let's solve that. So per the solution, what I'm going to do first here is that here, remember, we always integrate this one like this. Delta u delta x is always equals to what? M in terms of x and y. So when you are doing the integration, this will become delta u delta x equals to 2xy minus 9x squared. So now delta u equals to 2xy minus 9x squared x. Then at this point, what I'm going to do here is to integrate. So u is equals to, with respect to x, so here will give us x squared y minus 3x cubed plus a function of y. Are we seeing it? Then here we move to the next one. So who can guess the next one? I'm going straight. So here I'm going to integrate this one with respect to y, because always the n with respect to y, the x, the m with respect to x. So this one is going to be 2y plus x squared plus 1. But here I'm doing with respect to y. So I'm going to have this to be equals to y squared plus x squared y plus y plus j of x. And this is what we have. So let me come to this place. So we realize that as I did for the first one, this one and this are the same. This and that are the same. So what I have to do is I just compare. So if I pick f at y, then I'll come to this place and check where I can get y standalone, which is y squared plus y. So this is y squared, this is y. So they are all standalone. So this side becomes y squared plus y. Then I'll pick j of x. So j of x, when I come to this place, this is where x is standalone, which is negative 3x cubed. So this is what I have here. Now that I have this, I just pick any one of them. So if I pick the first one, which is x squared y minus 3x cubed plus fy. Is that okay? So I can clean this side now. So if you look at this one, fy, we have it here. So u is equals to x squared y minus 3x cubed plus fy, which is y squared plus y. You can also decide to pick the other one and use this one to do it. Now that we have this, you want to get the general solution first. First, you need the general solution. But you know that this, in terms of x, y, is always equals to c. Therefore, x squared y minus 3x cubed plus y squared plus y is equals to c. But remember that there was an initial condition given, so you have to do that to get a particular solution. So y is negative 3, x is 0. That's the meaning. So y is 3, x is what? 0, negative 3. So if I put 0 here, that will give us 0 squared times y, but y is negative 3, minus 3 multiplied by 0 cubed plus negative 3 squared minus 3 equals to c. All this one goes to 0, and this one will give me 9. 9 minus 3 is 6, so it means that c is equals to what? 6. So I just come back to this place and rewrite it. X squared y minus 3 x cubed plus y squared plus y is equals to what? 6. And this one becomes what? A particular solution. A particular solution. Okay, now. Okay, now let's look at a try work so that you go home and try. So this is your work.